being asked to factor this third-degree polynomial, but we're given one of the zeros. That means if we do synthetic division, this will work and give us a remainder of 0. So our polynomial has 3, 16, negative 5, and negative 50 as its coefficients. We bring down our first term 3. Negative 2 times 3 is negative 6. Adding down we have 10. Negative 2 times 10 is negative 20. We add to the negative 5 and get negative 25. Negative 2 times negative 25 is positive 50. And yes, we do get the 0, which is what we planned on. Now this is going to illustrate really well how the signs work here. The f of x, our polynomial, can now be factored into x plus 2. I get that plus 2 by changing the sign of that minus 2 right there, times 3x squared plus 10x minus 25. Now we can factor this second polynomial, leave the x plus 2 alone. We know we're going to have a 3x and a 1x, and it turns out it's 3x minus 5 times x plus 5, and if you check all your terms of FOIL, you will see that we have an outer term of positive 15, inner term of minus 5, and 15 minus 5 makes that 10 in the middle. So when you are evaluating a polynomial at negative 2, you actually use negative 2 itself. But when we're going back to factored form, we change the sign of that negative 2 back to x plus 2. Now we're being asked to solve this next equation. Now this is the same polynomial we just factored, so we now know we're going to have x plus 2 times 3x minus 5 times x plus 5 equal to 0. And our x values will be negative 2, positive 5/3, and negative 5. So those values themselves comprise our solution set. Here we're being asked to find a polynomial equation with these zeros. What we're going to do is rewrite it in the other direction. We're going to have x minus 5 root 2 times x plus 5 root 2 equals 0. If you saw this factored equation, you would just change the signs from the parentheses form to go to the solutions. We're just doing this in the other direction. When we multiply together, the first term of FOIL is x squared. The two middle terms are going to cancel out because we're multiplying conjugates by each other. So we're going to have minus 25 root 4 equals 0. That becomes x squared minus 25 times 2, which is 50, equals 0. Now that's an equation, and we were asked to find a polynomial with these zeros, so I'm going to write f of x is equal to x squared minus 50.